Now we can draw cost curve here. Cost curve we need from minus 110 to 70. So actually this positive part is not much needed. So here will be how much? 90 here, minus 90 here, minus 270. That is enough. Here we have plus 90. Okay, this is cos 70 minus theta. 0.6, we need 0.6. If we draw a line at 0.6, it will look like this. These 2 points, no? 0.6, we will have the answer in this is the y equals 0.6 line. So from the calculator, you can find how much is 0.6. How much is it going to be? Cos inverse 0.6. How much are you getting? 53.13. In degrees, you get 53.13. This angle here is how much? 53.13. Do we get that? Yes, it is less than 70. And in this side, how much will that value be? From the symmetry, you can understand it should be the same value here. It should be how much? Minus 53.13 also. Is it in the given range? Yes, both are accepted. Both are accepted. So our answers are what? We can write 70 minus theta equals to how much? Either 53.13 or minus 53.13. Now to find theta, this is not the final answer. Theta should be equal to how much? Now, if you make theta as the subject, theta is going to be 70 minus and 70 plus this amount, no? If you minus from 70, it's going to be 7 here, how much? 8, 6, 1. 16.87 or 123.13. These two values 16.87 degrees or 123.13. See, are these in the given range? Is it matching theta with this given range? Yes, it matches. If you substitute these values to theta, you will have this value. See, check. If you are not sure, you can just apply 70 minus 16.87, get the cost value. So it will be equal to 0.6 exactly. Who need more explanation? Please ask. Today we have time. We can discuss. Okay. If you have concerns, you can discuss. Is it clear that how did I get this range? That might be the messy part. These things you can do, like drawing the cost curve, find the relevant values, but identifying the range, I think it is the only new part compared to the earlier parts. Okay, question number 4. In question number 4, there are so many things. So let's pick up one. 4D. I have asked you to do 4D, no? 4D. I will now discuss the question number 4, part D. 4D. Again, they have given the wrong range, no? Put theta there. They have used x. Okay, so theta should be in between. Theta should be between 0 to 5. That might be the case. Some of you could not even try the homework. The questions were wrong. Unless I know you are the ones to do all the things. So we have to solve this one. How can we solve? We have sine and cos both. And we have to find solutions for theta in the range of 0 to 5. How? Ah. How can we solve? Now you can. We can't solve solutions having two types of ratios. If we want an equation, it's always easy to make it into one form of ratio. It might be cos, it might be sine, it might be tan. No. Now, in a situation where we have both sine and cos, it's easy to convert to tan. No. How? There are two ways. So easiest way will be you can divide this everything by what? Cos theta plus phi over 4. You might wonder, can you do like that? Yes, you can do. So I can write square root 3 sine theta plus phi over 4 plus cos theta plus phi over 4 equals 0. Everything I am going to divide by what? Cos theta plus phi over 4. Again divide by cos theta plus phi over 4. What happened to the other side? The other side also you can divide. Cos theta plus phi over 4. What's going to happen now? Sin x divided by cos x. What's the value? Tan x. It's the same angle. It's the same angle in the both situations. So what you can write? Can easily write here tan theta plus square root 3 tan theta plus phi over 4. It's sine ratio divided by cos ratio and the angle is same. So you can write it tan. Here it's going to be the same thing. Everything got cancelled off. So plus 1 equals 0 divided by anything is 0. So now we can make this part tan ratio only subject by taking this 1 to the other side. So it's square root 3 times tan theta plus phi divided by 4 equals minus 1. And if you make tan theta plus phi divided by 4 equals minus 1 over square root 3. See, we simplified this equation into this situation. After that, what we have to do? We have to find theta. If we make theta plus phi divided by 4 equals tan inverse minus 1 over square root 3. If you put in the calculator, you know tan 1 over 3 how much? Tan 1 over square root 3 comes for 30 degrees, like 5 over 3. If you put in the calculator, you will have minus 5 over 3. 5 over 6 actually, not 3. How much? 5 over 6 minus 5 over 6. This value you can get by the calculator, but we have to be mindful about the range our. This is our uh, range for theta, but we need to find for theta plus phi divided by 4. So what we have to do? We have to find the range for 0. I am going to add phi divided by 4 to everything. Theta plus phi divided by 4, and here also phi plus phi divided by 4. So theta plus phi divided by 4 should be like between phi over 4 and how much? Here we get 5 phi over 4. In within this is the, sorry, not theta. It is theta plus phi divided by 4. The range of theta plus phi over 4 is this one. why I divided, not the denominator. What I actually did was I divided everything by cos theta by plus phi over 4. I divided everything, all these two terms, actually three terms. I considered 0 also as a term. I just divided everything by cos ratio, cos this angle. Why? I needed to, like, I don't know how to solve equations with two ratios. I need it in one ratio. Like if you are asked to solve this equation, x plus y equals 8, can you solve it? No, there are two unknown terms. Like we don't know. So what we do, we find another value in y and substitute to this one, no? Like x square plus y equals 12 here. So from this one you can make y as the subject and substitute to this y. We need them in one unknown format. Similarly, when we are working with these trigonometric ratios also, when we are solving them, we can't find answers in two different ratios. So to take solutions, I need to convert them into one trigonometric unknown format. So what I did was I converted both of these to tan. How to convert tan? I can divide by cos. Okay, it's just a sum value. So I divided all the terms by cos theta plus phi over 4. So I got tan. That's how I did tan. So actually this is kind of practice you need. What kind of practice you should know? If I divide by cos value, I can convert, I will have only tan ratio. Every other term will cancel off because here it is 0, it's going to be cancelled, this will become 1. We have to have little bit of experience. Now this is the range for the tan graphs we should draw within that given range. So it will look like this. This tan theta plus phi over 4. Okay. These are going to be how much? 0, 5. This is 2 5 or 3 5 over 2. This is 5 divided by 2. This is minus 5 divided by 2. Anyway, we need minus 1 over 3. Minus 1 over 3 will be somewhere here. What are the values we can take? The value from the calculator we took was minus 5 over 6. This value was how much? Minus 5 over 6. Actually, you can think this as minus 30 degrees as well. Okay. Minus 5 over 6 is the value we got. But our range is in this what? 5 over 4 and 5 over 4. 5 over 4 means like here to somewhere here. You can clearly see with this relationship, it's only what? It's only this part. Somewhere here will be the only answer. How much? It will be similar to 5 minus 5 over 6. This value here will be equals to 5 minus 5 over 6. So it's going to be how much? If you take a common denominator, it's going to be 5 over 6. So our answer will be theta plus 5 divided by 4 equals 5 over 6. Why didn't I take this answer? It is not in our range. So we can't take the answers which are not in our range. So if we take a common denominator and solve, we will have theta equals 12 will be the common denominator. It will be 10 5. This will be 3 5. So 7 5. 7 5 over 12. Theta is equal to 7 5 over 12. Please comment it. Did any of you get the correct answer? Okay, no, yes. What about others who replied? Confused. Where you get confused? Ask me where you get confused. So is it like totally confused, or is it okay to come to this situation? No, there are certain levels of confusion. Some get confused identifying this range. Some get confused, how do I get to this answer? Some get confused, how did I use in that range? How did I find this answer? There are different levels of after 10. After 10, it's just solving the equation. Like it's so simple. Like after, if you understand this line, I think rest you can understand. Okay. So the best thing is to have a good understanding about this range here. Try to build from the given range. Now this is the given one to you. Always try to build this angle inside here without any harm to this inequality. Then you will understand what to do. Always try to build this angle. Now we have theta only. To have 5 by 4, what we have to do? If we add 5 by 2, 4 to all these, it's okay, it's correct. So 0 plus 5 by 4, that's why I did here. Okay. So yeah, mess with the range. Mess with the range. Which question? Then I am going to do question number 6. Please copy this down and look at the question number 6. Don't think these things as hard, okay? If you think this as hard, imagine yourself uh, acting like Shavendra Silva. Is it that is hard or doing these sums are hard? Being Shavendra Silva, doing these sums. So when I give you some time to work on the questions, please do them. Please give your maximum effort. Okay. Okay. Let's see. Question number 6. Question number 6. Sketch graph. Okay. Now, what is in the question number 6? 0. X is between 0 to how much? 2, 5, no? X is between 0 to 2, 5. Within that range, we have to draw the graph of y equals sine how much? X plus 5 over 4. Is that what we have to draw? Sine, sorry, 5 over 3, no? Y equals sine 5 over 3. How can we draw it? How can we draw it? Now think, if we are asked just to the within this range sine curve, sine x curve, it's easy, no? Just 0 to 2, 5. It's like this. This is 2, 5. And this is sine x. We could have done it easily. Now the range is little bit different. What is the range? Sorry, not the range. The inside angle is little bit different. How can we draw it? How can we draw it? Here, try to build this part. Let's find the, at first we have to find the range of this x plus 5 over 3. So I can add 5 over 3 to everything. So 0 plus 5 over 3 and x 5 over 3 and 2 5 plus 5 over 3. So the range of this value is how much? 5 over 3 comma, and here how much? X plus 5 over 3. It's x plus 5 over 3, and here we have how much? 8 5 plus 5 9 5, no 9, not 9 5, 7 5, no, 7 5 over 3. This is the range of x plus 5 over 3. Then what we have to do? Have to sketch the graph. How can we sketch? It's not going to be same as we did earlier. Now we have to draw. Here this axis is x and this is sine x plus 5 over 3. Think it will be really easy if you think substitute some values for x. If you substitute some values for x, it is going to be a little bit easy. So sine x plus 5 over 3. How can we draw it? Here, what we can do here? If we think x equals 0, how much will be sine? If x is 0, sine 0 plus 5 over, sine 5 over 3, sine 60, square root 3 divided by 2, no? So start with this somewhere here. Let's take this place as 1, square root 3 divided by 2. Then when this part is going to be 0, when x equals minus 5 over 3. So actually if you think more and more values, think again what, when can we make 5 divided by 2 inside? If this part equals to how much? 2 5 over 3, no? No. If x equals, let's say, how much I need? 5 divided by 2 equals x plus 5 over 3. So 5 over 6. So at 5 over 6, it's going to be this way. Now, if you think some values, it's going to be what? Like this. Yes, this part, if you are confused about that part here, uh, please go to, this is a miss part that I did not teach you. P1, what is the part? We have a part called transforming trigonometric graphs, page number 128. Okay, page number, sorry, 125. P1, page number 125. Please have a note here. I'm going to discuss that part, little part here. That's the missing part. Okay. So before doing this question, I'm going to discuss that part with you. Okay. Just forget all of these. Just forget all of these. Question number 6. I'm going to teach you this part of P1, because I told you when I am doing this lesson, I will discuss that also. So the previous things are okay. Now only this is the missing piece. So transforming trigonometric graphs. First, let's try to draw y equals sine theta graph. Y equals sine theta. If I draw y equals sine theta here, how will it? So theta is here. This is sine theta, no? Or y. And it will look like this. This is how y equals sine theta graph. Now, what's going to happen? If I am going to give a little bit of a addition, external addition to this graph, I need to, now this is y equals sine theta graph. In the same graph, I need to find how will it look like sine theta plus 1. What? Sine theta plus 1. What will happen? Now try to remember the lesson that we did, transformation of graphs. Just think about this one. Y equals x squared. How will look like the graph? Graph will look like this, no? Y and x is here. What if I am to draw the y equals x to the power 2 plus 2? What will happen to this graph? This graph will move 2 units upward. No? This graph is moving upward 2 units. And if it is like minus 2 here, x squared minus 2, what happened to this graph here? It goes down 2 units. We did so many transformations. Can you remember at the school in the month of, I think, April or March? Okay. This goes 2 units down. So what happens if I add 2 to this one? Like, not this one. Now we know only this is how this way. This y, this is x. What if I just add this x plus 2 to the power 2? How can I find y equals x plus 2 to the power 2? This is internal addition, no? Earlier it was a external addition. So that this graph move up and down, no? Now this is an internal addition. What happened? If it is addition, it goes to the left side. If it is a subtraction, it goes to the right side. I hope you can remember those things. This comes to minus 2, no? This axis comes to, this symmetrical axis comes to minus 2, no? So likewise, what's going to happen in this here? For the internal addition, it has a which kind of a movement? Horizontal movement, no? The graph goes here and left and right. For external additions, it goes vertically, up or down. Now, think about this situation here. Sine theta plus 1. Is this an internal addition? No, external addition. This is a external addition. This was our original. Y equals sine theta was our original equation. To that, we add the 1 externally. So what's going to happen? This total equation going to shift how many units? 1 unit upward. That means now we have minus 1 and plus 1 here. So these points, all these points will shift upward 1 unit. So the final curve will look like this, no? Something like this. Something like this. All these points will move 1 unit upward. This is a which kind of transformation? This is an external transformation. If there is an external transformation, graph will either move upward or downward. No, total graph, total shape will move upward or downward. If we add or subtract from the outside, for cos, for tan, for any, that will be same. All these crossing points move up or down, move up or down. Is it clear? Now, if I ask you to draw the graph of y equals cos theta minus 2, what will look like the graph? First, draw the cos theta curve. Then you will understand what to do. Cos theta curve will look like this, no? We have already drawn 1000 times this thing. Okay, cos theta curve will look like this. This is cos theta curve, no? Y equal cos theta. So minus 2, what is going to happen? All these critical points are vertically going down 2 units. So here this was plus 1, this was minus 1, no? So all these units will go downward. So it's kind of how much? If you draw a line at here 0, this was the original our x line, this will look as our new x-axis, no? This is minus 2 here, and this minus 1 value will goes to minus 3 also. So how will it look like? It will look like this way, no? Like this. Like this. All these units still transfer 2 units downward, no? 2 units downwards, because there is external 2 units are subtracted. So if change is given externally, graph is going to move up or downwards. Keep in mind, we already did those stuff. Okay, in graphs transformation, these are also similar to that. Now let's try to observe what happens if we are going to give a internal transformation. External transformations are kind of easy. Now internal transformations, sometimes they get little bit trickier. Okay, like this. If the internal transformation is like this, y equals, we know our base equation is this, y equals x plus 2. What's going to happen? We know that our graph is going to move 2 units to left side, no? The symmetrical axis of symmetry moves 2 units left side. Similarly, if it was like y equals x minus 2 power 2, then this moves right side 2 units. It's horizontally moving, no? It's just addition or subtraction. What's going to happen? The same graph is going to go right side, or same graph is going to go left side. Same thing applies for sine curves. Now we know what is y equals sine theta. I am again going to draw that same thing. Okay, this is theta, y equals sine theta. Okay, in the same graph, I need to understand how will it look like. Y equals sine theta plus 5 divided by 4. These internal additions, keep in mind, they are not like, we can't give in integer values. Why? These are degrees of radians. So we have to give inputs for sine in degrees of radians. Okay. Now what is going to happen? Now what is going to happen to the graph? What do you think? If it was addition, in normal curves, it goes to left side. Similarly, same thing happened to these sine curves. Same thing happened to sine curves. What is happening here is, this same graph is shifting. How many units? All these points go 45 degrees. 5 divided by 4, let's, for the easiness, I am writing 45 degrees here. All these points are going to go 45 degrees left side. All these points. Okay. Same graph. So these are like here 180, 360, minus 180. All these critical points shift 1 unit, sorry, how many? 45 degrees backward. This is 90 degrees here. So try to draw one line, try to draw this graph yourself, all of you in your books. Try to draw this graph. Y equals sine theta plus 45 degrees. Okay. So what's going to happen? This graph is moving. How many? All these critical points. We know this maximum value happens as angle equals 90 degrees. So at that point, it goes backward. It goes backward. See, you can always think in this format. Y equals x to the power 2. Graph will look like this. What will be the graph of y equals x plus 2 to the power 2? You know this axis of symmetry. How do we get that axis of symmetry? We take it by making this part equal to 0. So x plus 2 equals 0. So x should be equals to minus 2. At minus 2 is going to be the new line. This is x. This is this equation. No? This is minus 2 here. If it is an addition, it goes backward. If it is a subtraction, it goes forward. Now, at 135 degrees, it's going to go for 0. No, this is a little bit tricky. At 180, not 180, 100, 225, it's going to be top. No, something like this. This is what? So this point will be how much? 135 degrees. This point here will be how much? 350 degrees. The point of intersection. This is going to be minus 45 degrees. This is going to be 225 minus degrees. This black line is what? Sine theta plus 45 degrees. Blue line is sine theta. Now, if you are done with this part, try to draw this graph. Y equals cos theta minus 60 degrees. First draw y equal cos theta graph and then try to understand what is happening to all the points. First draw y equal cos theta, then try to, on the same graph, try to draw cos theta minus 60. What's going to happen? All those points will shift 60 degrees forward. No? Hmm? Epa. Betul. Betul. Mana dia nidagan. Nidagan. Eh? Tunggu. Pasti ada. Nah, tuh apa? Now, if you have wondered how these graphs are like, if you are not sure whether it is going backward or forward, just substitute some values, substitute some angles. Then you can easily see. We draw these fundamental graphs also using what? Some values. It's not from some sort of a magic. They were drawn using some values for theta. Okay. So similarly, you can substitute some values for theta and think of the curve. How will it look like? Then it will easily you can plot it. Okay. Cos theta curve is going to be looking like this. Okay. So this is going to be how much? Theta, and this is cos theta. Okay. So minus 60. So if we are like trying to remember it like a parrot, you can just think it's going to go forward how many? 60 degrees. This same graph will shift forward 60 degrees. Same graph will shift forward how many degrees? 40, sorry, 60 degrees. What is this happening here? Okay. What's going to happen? This point now, this is at 0. At 0, it is 90 degrees. Now at 60 it's going to be 90 degrees. And this was, see, it was 0 at 90 degrees. Now it's going for 150. And it's coming down here now. And in this side it was minus 90. If you go 60, it's going to be minus 30 here. At minus 30 it's 0. So like that, what's going to happen? It's going down. This was 270. Now it's 330. This value is 330. Okay. So like that. Earlier it was here 180. Now it is 240 degrees. So like that. Like that. Curve will be like that. It is cos theta plus 5 over 6 minus 60 degrees, no? 5 over 3. I think that knowledge is enough to do the question number 6 part A. Actually, so then I think you don't need to worry about too much about the range, no? You can just draw the graph. I think I messed you with that range there. So no need to worry too much about the range. Just draw the graph. What is in the question number 6? In this question number 6, draw the graph of y equals sine 5 theta plus x plus 5 over 3. X plus 5 over 3. X is between 0 to 5. Okay, just don't worry about the range, just draw the graph. Okay, so here what's going to be the graph? Sine theta. First I will draw the sine theta curve. It is this. So now I don't have the ability to check all of your graphs, makes them much nicer. Okay, even in the whiteboard I erase and draw again and again. So you have so many rules in your books, so use them and draw these graphs so symmetrically. Then this is the y equals sine theta graph. Now we have 5 plus 3. This plus, if it is addition, it is an internal addition. What's going to happen? Is it moving forward or it's going backwards? All these points are going to move how many degrees? 5 over 3 means like 60 degrees, no? 60 degrees backward. So this 0, here it was at 0, now it is minus 5 over 3, like 60 degrees here. And earlier it was at 90 degrees, 5 divided by 2, it goes back how much? 5 over 6. So 5 minus 2, 5 over 6. How much? It's going to be 3, 5 minus 5. So 5 divided by 3. So it's going to be at 30 degrees, no? So the maximum value will be at 30 degrees. And it's going to be 0 at 120 degrees. All these points are shifted how many points? 60 degrees backward. So what is the given range? They are asking 0 to 25. 25 was earlier here. Now you have to think at 25. Now what's going to be at 25? What is the value of x at 25? Earlier it was 0. Now the zero comes at not 2 5, not 1, 360 at 300 degrees. No, what happens if you go 360 degrees more? It's going to be square root 3 divided by 2. No, it's not at the topmost level, but closer to some top level here. Okay, actually, you don't need all these. You need only the red line between this 0 to this. If you can draw like this, it's fine. But drawing some additional parts is going to helpful for you. It will be helpful for you to understand these points of intersection. So it doesn't matter if you extend it little bit further. Now this is 240 degrees. In degrees, I write them in degrees because to make some sense to you. This is going to be how much? 120 degrees. This value here is going to be 30 degrees maximum value. And here minus 1 will come at where? Earlier it came at 270. Now it is coming at 210 somewhere here. Okay, 210 like that. Oh wait, where I missed. This should be at 300, not 240. Yes, this will be the most crucial point. Question number 6, part A. Okay, then what are they asking? Write down the exact coordinates of the point where graph meets the coordinate axis. Exact coordinates of the points. Axis. Now you can see in which situations this graph is meeting axis, y and x axis. Y axis meets at which point? What is the coordinate? X is 0 and y is going to be how much? Sine phi divided by 3. This coordinate here, what is the coordinate here? I would name these coordinates A, this is B, and this is C. We have 3 coordinates in the given region where this line, this curve is going to meet the given axis A, B, and C. Coordinate A, what is A? At that point, you can easily now know the x value. X coordinates are what are those? 0 degrees, and how much is going to be y? If just substitute 0 here, sine 0 plus 5 over 3, sine 5 over 3, how much? Sine 5 over 3 minus, sorry, square root 3 divided by 2. This is A. What is about B? B angle is 120 degrees, or in, yes, 120 degrees. What about the y value? Y value is 0, no? So 120 degrees, comma 0. Or you can write the same thing as 2 pi over 3, comma 0. Because I wrote in radians because the range was given in radians. So it's better to write those in radians. And what is that? This point here, it's going to be 300 degrees and 0, or other way, 300 degrees, how can you write? 5 pi over 6, no? So 5 pi over 6, comma 0. Not 5 pi. I did something wrong. 5 over 6. It's going to be 2 pi over, sorry, 5 over 3 into 5. So it's 3, no? 5 pi over 3, comma 0. These are the coordinates. Now see, even these coordinates, one coordinate is coming in radians or degrees, other one is just a value. You have to see those things. Okay, what else? What else do we have? Solve for 0 to x 5 the equation sine x plus 5 over 3 0.55. What do we need? 0.55. So now I will draw the our required curve only here to make more sense. It's something like this. This is the same line, no? This will be sine phi x plus it's going to be how much? 120. Here we have 300. Yes. This is going to be 30 degrees. And this is going to be how much? 210. Okay. So what are they asking? 0.55. When will this sine x plus 5 over 3 equals 0.54? This curve equals 0.55. How much? So this value is, I think, more than that, no? 0.86. Okay. Now 0.55 will be somewhere here. Now these two values are going to give us exactly the given needed value. Now this, if you compare with this question with the earlier situations, you don't need to worry about going anywhere. If you can draw straightly this graph, you can straight away take these are the answers for x going to be. Answers for x going to be these answers. So using the curve, we will have to find it, no? So how much will it? Now you can't even use the calculator for this one. This is not the standard sine curve. If you use sine curve, like if you need to going to find the value from this one using the calculator, you are not going to get the proper values. You are not going to get these values. You are going to get the values that are taken from this blue curve here. Oh, how much will they be? It's a little bit hard to get answers from this curve. That's why we did the other way. Okay, anyway, here how much is going to be? Are they asking to use this curve? No, no. 0 point. Now if you apply in the calculator and get like sine inverse 0.55, how much you are going to get? If you apply in the calculator, you are going to get how much? 33.36 degrees. No, I'm talking about the part C. Okay, 33.36 degrees. Now from this graph you can clearly see these values which give you 0.55 are not equal to 33.36. See, 30 degrees is here, 33. It's not going to come here. It should be more than 60 degrees, no? So why is this change? But if you look at this curve, you can easily get that, this blue curve, from the blue curve. So you will have one cut here and another cut here. From these two positions you can pick up at and go on. But the point now, what's happening? This curve has been stretched. So I think I'm making it a little bit harder for you. What to do? Just forget this way. Now if you have to draw a transform graph, do this way. But finding solutions using this graph is little bit hard because our calculator does not support with this one, no? So, but it's the same thing you have to understand. You can use that value that is coming from the calculator to find this value here. Yep. Now come back, it will be the same value. Okay, never mind. Just for the next part, for the part C, just use the old method. Okay, don't use the new curve. It's not going to help us. Okay, use the old method to find the value. So we just draw the graph of sine x. This how much is going to be sine? Okay, what x curve? So sine x plus 5 over 6, and this angle is x plus 5 over 6 will be here. Okay, now I am also a little bit confused. From this one, how did we get? We got sine x plus 5 over 3 equals to how much? 0.55. So we can get x plus 5 over 3 equals sine inverse 0.55. What is the value? From the calculator you can have how much? From the calculator you can have 33.36 degrees, no? That's the value you can get from the calculator. Then we have to be careful about our range. Range was given 0 to 180 degrees. No, I will use here degrees to reduce the confusions. So we have to check whether this value is 60 degrees here. No, so I am going to add 60 to all. So 0 plus 60, x plus 60 should be here 180 plus 60. So our new range should be between how much? 60 and x plus 60 here 240 degrees. So we need this graph in between 60 to only, we will care only about the results that are coming from 60 to 240. That's what you have to understand. So where is 60 degrees will somewhere here, no, yes, somewhere here 60 and 240. This sine curve we have here 270 degrees, here 360. So now we just draw a line at 0.55. So we get the answer here 33.36. Do we accept it? No, because it's not in our range. Our range is from 60 to 240. So we will have to accept this value here only. This value also out of our range. So this is our answer. This will be our answer. So what's going to come? 0.55. So it's going to come here. This gap here is from the main principal range we got 33.36. Even though we don't get this as a correct result, we can use it to find the other one. Okay, 33.6. From we know from the symmetry, this same gap should be here. This value is 180 degrees. So from that gap, we can find this value here. How much? 180 minus 33.36. So that value is going to be how much? 146.64. So we can get our answer for this equation. How much? X plus 60 degrees is equal to 146.64. So if you subtract 60 degrees from both sides, you get 86.64 degrees. This is the answer for X. Now I did it in the old method. This is the method that I was talking to you from the beginning. For the first two parts, to identify the transformations, that is enough. Is it clear or is it totally confused? I think I make some confusions there. Okay, let's see along the way, like when we do the next part, all these confusions will go away. I'm pretty sure. Like the next exercise, they will fade away. Try to do the question number 8. Question number 8. Uh, Sorry, man. There is a little mistake I have done here. This range is not to 180. It is given 360 degrees. I took it to 0 to 5. It's 2 to 5. Okay, 360. So this is going to be 420. So it's not just here. It's 420 degrees. I think one answer is going to come here as well. We think 420, no? So this answer is also acceptable. So you have to add this gap, little gap, 33.36 to 360 degrees also. So 360 plus 33.36. So that's going to be the other answer for x is going to be how much? 396.6636. Okay, it was not 0 to 5, it is 0 to 25. That's a mistake. Yeah, I should not select this kind of questions next time when I am explaining. It kind of make you confused, no? Because we drew two graphs actually there. First graph is transforming the given graph, and we use the original graph to find the solutions. So when you are finding solutions for the equations, this is the best method, okay? Okay, question number 8. Try to understand question number 8. Last one. After this, I am going to give you like 5-minute break. So I think nobody has an issue with if I am doing beyond 1 p.m. Huh? Okay. Okay, I will give 10 minutes. Question number 8. What are they asking? The equation tan kx equals how much? Minus 1 over square root 3. Where k is a constant and k is a positive constant, no? K is greater than 0. It's given. Has a solution at x equals 5 over 3. Now we have a solution for this x equals how much? 5 over 3. Okay. Find the possible value of k. State with justification whether this is the only such possible value for k. Try to do find the possible value for k. What is mean by solution? It should, this value should satisfy this equation, no? So if we put here tan k times 5 over 3 should be equals to this minus 1 over square root 3 as well. Now you can find what? You want k times 5 over 3 equals tan inverse minus 1 over square root 3. If you go to calculate and get a value, what's going to come? It will be, you get minus 30 degrees, or in radians minus 5 over 3, no? 5 over 6. So k 5 over 3 is equal to how much? Minus 5 over 6. That is what you get from the calculator, no? Why I wrote in the place of x 5 over 3? Because it satisfies. So if I am solving like this, what is the value I am going to get? K equals how much? 5 to 5 cancel off, 3 and 6 also cancel off, minus half. Can we accept this answer? No, we can't. Why? We are saying k is greater than 0. Now what we have to do? We have to do what? Do a little bit of a search. If we draw some tan curves, you will identify. See? Let's draw some tan curves here. So this will be 0, 90 minus 90 degrees. It's going to be how much? Tan theta. This is theta. And what do we need? We need the values where this is minus 1 over 3. The solutions. Solution set will come at minus 1 over 3. So from our principal solution, we got this one, no? Minus 5 over 6. This is what is coming from the calculator, but we can't accept it, no? They are asking what? Find a possible value of k. Now, from this symmetry, you know, it will, the same answer you can take from here also. What is this value here? This is 180 degrees, no? Or 5 degrees here. So 5 minus 5 over 6 will be here. So what is the value here? 5 minus 5 over 6. How much? 5 over 6. This value here is going to be 5 over 6. So instead of this one, what we can do? Without writing this one, we can write it as k times 5 over 6 should be equals to 5 over 6 as well. We can't accept this because k cannot be less than 0. Okay. So in this situation, how much are we taking? K equals 5, no? That is a one value. That is acceptable. K is greater than 0. Okay, we found one value for k. What else? State with justification whether this is the only such possible value of k. Is this the only value of k? What do you think? No, we can find infinite values for k. Here also you can get a value. If you draw more and more, it will come no the same answer. So what's your answer for part B? This is just enough. They are asking just find a value for k. This is enough. For the part B, what you can say? No, there are infinite number of solutions for k. In the graph you can see it, no? If you find another value here, how much is going to be? This is going to be 325. 25 minus same value. So 25 minus 5 over 6. How much is it going to be? 12 5, 11 5 over 6. So, oh wait, I did something wrong here, no? This is 3. So, it's going to be 10, not 5. 5 5 over, sorry, 5 divided by 2. This answer here will be 5 divided by 2. K will be equal to 5 divided by 2. And here will be, the answer will be 11 divided by 2, like that. It goes on. So you can find so many solutions. No, it's not the only thing. From the graph we can see there are so many solutions for K. Clear? Need more explanations? Or just need to get off with this lesson, like finish the lesson, no? No, you will feel easy when we are doing past paper questions, okay? Just don't worry. Okay, now it is 12:48. Shall we be back at 1? Okay, be back at 1. Be refreshed, and I will do some questions in the. I will finish this lesson now. In the within 1 hour we can finish, and if we have time, I'm trying to do some past papers as well. Let's see how it goes. Okay. Okay. B. Answer for B is no. There are infinite number of solutions we can see from the graph. Okay. This is not the only value. Okay, see you at 1. Okay, now good. Now you know the rules, huh? All of you know the rules. Hi, vanakkam. Hi, hi, hello. What is PB? I don't, I don't know. PB, PP, whatever. Okay. See, you can see who can finish this first can have the freedom to move like disconnect. Exercise. What do we have? 6E. Okay, exercise 6E. How to solve? Look at the questions now. Now we know how to solve trigonometric equations. Now we are going to include the identities. What are the identities we learned so far? Oh, we learned tan theta is equal to identical to sin theta divided by cos theta. And what are the other identities we learned? Sin squared theta plus cos squared theta equals 1. We are including these two identities in the upcoming questions. That's the only thing. We already learned how to solve trigonometric equations. To those equations, we are going to substitute. We are going to use these two identities. That's all what we are doing in the next part. Okay, let's see what do we have. Question number 1A. Solve theta. What is question number 1? ACDG. I'm going to do ACDG. Please try them. Solve for theta in the range 0 to 360. Solve for theta. Theta is between 0 to 360. Actually, these are not harder like the earlier section. See, give answers to 3 significant pairs where they are not exact. Okay. What is the first one? 4 times cos square theta equals 1. A. 4 times cos square theta equals 1. How can we solve? There are three methods that you can get the answer. First one, I'm a real fan of completing squares. So I'm going to take one to the other side. 4 cos squared theta minus 1 equals 0. I see this as difference of 2 square. So I'm going to write this as 2 cos theta power 2. So get the power 2, for 2 to the power 2, 4 cos theta to power 2 cos square theta minus 1 to the power 2 equals 0. Now I see what? Difference of 2 squares here. What are the factors of difference of 2 squares? I can write this as 2 cos theta minus 1 or 2 cos theta plus 1 equals 0. Now, two things getting multiplied then equal to 0. So, we can separately equalize to 0. So, we have cos theta, 2 cos theta minus 1 equals 0 or 2 cos theta plus 1 equals 0. So, cos theta equals half or cos theta equals minus half. Cos theta equals half or cos theta equals minus half. So theta is equal to how much? Theta is equal to how much? Cos inverse half or theta equals cos inverse minus half. But from here onwards, it's same as we did earlier. Now you need to draw the cos curve. What is cos curve? This is going to be the cost curve for 0 to 360. We need two values, 0.5 plus and minus. So we have one value here and two values here because we are from 0 to 360. 360 is here, no? Not three, four values actually. We have four values. We are going to get how many values? Four values. All these values are going to come as answers. Here, theta, positive half. We know this on cos theta, cos half comes from 5 over 3, like 60 degrees, no? Even if you apply in the calculator, you will have 60 degrees here, comma, here how much? This will be here 270 plus 60, 330. Other value will be 330 degrees. And what else we are getting in this minus half from the symmetry, we can see this is also should be 30 degrees apart from here. So 30, 90 plus 120 degrees, other one. And here it's going to be 240 degrees. These are the answers. I don't think this is hard compared to the last sections. These are really easy ones. It's like solving equations. Really what you have to do here is, in this part is, these parts are we done earlier. After coming to this kind of situations, how to get the answer. We did earlier. Now this is the earlier part, like solving this part. Taking common things out, factorizing, and dealing with this. This cos theta. Anyone need any explanation? Anyone who doesn't understand this, please raise your hand. If you raise hand, I am not hearing you, so please comment. Last part. What do you mean by last part? How did I get these values? I think it's okay to get cos inverse half and cos inverse minus half. Okay. Thereafter, how did I get these solutions? So from the calculator, if you apply in the calculator, you will have these two answers. How much? 60 degrees and 120 degrees. Do you get? I think so. Cos inverse minus 0.5, and from the calculator you can take those. Yes. But how did I get the other two values? Can I just stop at getting these two values? No, you can't. Why? They have given a range for theta. So I have to look for all the possible scenarios where I can have the values. So what I did was I drive the cos theta curve. So draw the cos theta curve in the given range. This is sin theta curve now. So I drew the cos theta curve for the given range. So cos theta is 360 here, 90, 270, like that. Okay. Now, if I draw a 0.5, if I draw a 0.5, because these were the solutions, 0.5 and minus 0.5. So this curve, if I draw a line at 0.5 and minus 0.5, I get how many points does this line is going to cut? 4 times. One here, one here, one here, and one here. Now, from the calculator, what we are getting is these answers. This value here and this value here. These two values we get from the calculator. But if you look further, these two positions, this and these two values, there are two more values. So how do I identify those are from this graph and using the symmetry. I know this value is 60, it gave me the calculator, and I know the gap here. What is the gap? Gap is going to be 30. This gap is going to be 30. So the same gap will be here also from the symmetry of this graph. So I know this value is 270. So 270 plus 6. Oh, wait. I think it should be 300, not 330. Should be how much? 300. Why? This gap is just 30 degrees. Thanks for asking. Was that your question? That okay? And this gap, yeah, that is correct. This 270 degrees minus 30. It's going to be 240. It's correct. Okay. From the symmetry of the graph, I picked up these two values. Yes, not only just to check, we have to find if there are more values, we have to pick up those values from the graph. That's only these two from the calculator, and with the graph we can see there are more positions where we are going to get the same values. So from those we get okay. For part C, I'm going to do part C. Part C. What is part C? Part C. We have 3 sine squared theta plus sine theta equals 0. 3 sine squared theta plus sine theta equals 0. Now, these are two-step solution for these equations. This is like two-step solutions. Like in algebra, if you are given 3x squared plus x equals 0, how you get the answer? What are the solutions? Solutions are going to be, you can take a common factor out. Sometimes when you are so deep in the equations, you can't see that easily, you can factorize this. So 3x plus 1 equals 0. So now this is two things getting multiplied then equal to 0, same as the earlier situation. So either x should be equal to 0 or 3x plus 1 equal to 0. Make sure you don't divide by x in these kind of situations, okay? If you do it, you're going to miss some solutions. It's wrong. Okay, so who left? Whose Wi-Fi went off? I think it is Simaj. Okay. Uh, oh, what do we have here? Uh, you know, now we have x equals 0 or x equals minus 1 over 3. Now this is finished in normal algebra. But in trigonometry, this is not finished. We have to do more, no? So likewise, let's try to do it in this trigonometry part. What to do here? So here I can take sine theta out as a common factor. So I have 3 sine theta. I don't need to convert this into any. Why? Everything is in sine theta. Plus 1 equals 0. So now we have two factors getting multiplied then equal to 0. So we can separately write either sine theta is equal to 0 or 3 sine theta plus 1 equal to 0. So we have sine theta equals 0 or sine theta equals minus 1 over 3. So what is the range again? Range given to us is from 0 to 360, no? 0 to 360. So from the calculator, you can get two values, no? So if you get how much theta is equal to sine inverse 0. Sine inverse 0 will be again 0 degrees as well, no? So that is the value you are going to get from the calculator. Here also, you will have theta equals sine inverse minus 1 over 3. If you put in the calculator, you will get a value. You are going to get actually a negative value, no? Let's see how much you are going to get. Sine inverse 1 over 3. 19.47. How much? 19 minus 19.47 degrees, huh? Theta equals how much? Minus 19.47 degrees, no? These are the two values you get from the calculator. Can we accept those two? This is acceptable because it is given in the given range. What is the given range? 0 to 360. They have told us theta is between 0 and 360. This is acceptable. This is even not acceptable. So we have to check for the values using the curve. We have to draw the sine curve now from 0 to 360. So when I draw like this, now sine theta, this is theta curve. It's okay to always draw little bit extended version, okay? No need to just stop at the, so here it is 180, this is 360. We got the solution, one solution at 0. What are the other solutions this line is going to cross? It's going to cross at here also, here also. So 3 points from 0 to 360. At how many points we have 0? 3 points. So this same value we can get at 0, 180 degrees and 360 degrees, because this can be equal to both 0 and 360 degrees. What about this value? We have minus, it's almost like minus 20, no? but I will write minus 19.47. What are the other values? We need minus 1 over 3. That value you will have at these 2 points, no? This minus 1 over 3. This 0 here, no? So that value we are going to have in two locations. We need the angles in these two locations as well. How to get up those locations? How to pick up those locations? We know this gap, it is same gap in these situations also. We know these angles, so by adding to those, we can easily get those values. So other one is going to be 180 plus 19.727. How much is it that? 180 plus 19.47. So it's going to be how much? 47 199.47 degrees. That is one. Other one is 360 minus 19.47. It's going to be 350. Yeah, we have 4 340.43. So altogether, how many solutions? We have 5 solutions. Okay. So theta can be equal to 0, then 180 degrees, then 199.47 degrees, then we have 340.53 degrees and 360 degrees. All are acceptable. In this equation, if you substitute 0, this will satisfy. If you substitute 180 here, it's going to satisfy any angle. Okay, any angle you are going to substitute that match with this given equation. Hope all of you understood now. Now, little by little, it is making some sense now. Now, think the beginning of this lesson. Beginning of this lesson. If you go back to the beginning of this lesson, earlier when I draw these sine and cos curves, they were like, yeah, they were really hard, no? Understanding that sine theta equals x, y value, cos theta equals x value. Those were hard, no? Now, those things, if you are given to talk about, anyone is talking to you about the curve, now it is much familiar to you. Why? Now I have drawn it like 100 times again and again, no? I think you also writing them in your books. So it becomes, when you are familiar with the things again and again, what's going to happen? You know what is happening, no? Like you think about the people in the gatekeepers or the lab assistants in the Universities, sometimes they know better than the instructors. They have seen the same experiment done by students for 20 plus years, 15 years, more than 10 years. So they know exactly well what is we are testing when we are doing experiment, what are the correct procedure and everything. If there are no instructors, even the lab assistants, like the people who are there to keep the equipment clearly and clean, they know how to do this. So like that, when you get used this, even though you don't 100% understand, it's more natural to you. See, only thing is you have to spend time with these. That's the key. That's the key. What is the key? Spend time with this. Then things will go into your mind automatically. If you don't spend time, you spend like your time, I would say 90% of time on something else like gaming or whatever other thing, and just try to take this within this period only. It's very less chance. Okay, I would say it's a very rare chance. It's a very extremely rare situation. You are just going to grab it within this time only. If you spend time, even though you don't understand, yes, you will catch it. Okay, D, part D. What is D? What is D? What do I get? Tan squared theta minus 2 tan theta. Tan squared theta minus 2 tan theta minus 10. Minus 10 equals 0. Now everything is in the same ratio. No need to worry to convert this. Now what we can do? We can just see it as like x squared minus 2x minus 10. Then it's just finding factors. Now minus 10 and minus 2. Do we have factors? I don't think we have easy factors. Do we have easy factors? 5 times 2 will be the only thing. So it's anyway, it's not going to come. So we have to use the equation, no? We have to use the equation. So using the equation, what is the equation? X equals minus b plus or minus b squared minus 4ac divided by 2a. I rarely use this. You can even use completing square method also. Okay. So what do we have? Tan theta equals minus b means minus 2, no? Minus 2 plus or minus b squared minus 2 to the power 2. How much? Minus 4 times a is 1. And here minus 10 divided by 2 into 1. Now does it look like alien? You might have used this equation in the equations where you have x. No, it's for any variable. Here tan theta is the variable. So you can use it to anywhere. Okay. So we have how much? Tan theta equals plus 2 plus or minus 4, and here 44, 40, no? Plus 40. So 44 square root 44 divided by 2. Actually, we can take a 4 out. It's going to cancel off. So tan theta equals how much? 1 plus or minus square root 11. So we have two solutions. It should be, no? It should have two solutions. Why? It's a quadratic equation. There should be two solutions. So either tan theta should be equals to 1 plus square root 11, or tan theta is equal to 1 minus square root 11. Now using the calculator, you can find two values for this. Find those two values. How much? 76.956. So it's better 96 now. 76.96. 76.96. And then the next one, they have asked for three significant figures. No, when we are going for three significant figures, actually we can just write this as 77 degrees. I forgot that they are asking for three significant figures. This one, how much are we taking? 66.7. So minus 66.7 degrees. Minus 66.7 degrees. Now think, what are the possible? Can we accept this one? We can't even accept this. Why? It is in the minus range. But the given range is from 0 to 360. So we have to draw the tan curves from 0 to 360 degrees. Just draw them very quickly. Please, anyone having is hardships with this drawing these curves, please contact me. I don't think anyone has. So tan theta. What are the values? 1 plus square root 11. It's like something 4 something, no? We just draw a line here. We just need that is positive and this is negative. That's what we all need. This value came here at minus 67, no? Minus 67.7. That one came on this plus 77 here. This is acceptable. Why? It is in the given range. Now our given range is here to here. What are the other values? This is 360 degrees. Now if we look at the values, it's going to cut at here. That's need. It's going to cut at here and cut at here. So how many solutions? We have 4 solutions. Here, 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 and here. How can we identify those? One is from this one you can take, and here same gap. How much is this value? Is 180 degrees. So 180 plus this 77 degrees. So actually theta should be equals to how much? We can't accept this one, but it is helpful for us to find the other values. So 77 correct, and 180 plus 77, how much? 257 degrees, no? Then this one, this is same gap as here. This value will be 180 minus 67, 66.7. How much is it? It's 66. It's going to be 114, 113.3. 113.3. And here 360 minus this amount. This value here is going to be 360 minus 66.7. So it's going to be 100, 293.3. These are the 4 results for theta. Did all of you understood? Sonal, what about you? Okay. Now you might wonder, can't we use this equation for the earlier quadratic type? Yes, you could have. You could have got the use the quadratic equation and get the same answers like the very first one I did, part A. Now you can try part A with the this equation. Again, you will have the same answers. It doesn't matter whether which method you are. It's like solving quadratic equations. You can use different methods. In question number 2, I will do the part D as well. Okay. I'm not going to do the fully, but I will help you with some points. Question number 2, B and D both. Okay, now I'm going to quickly do the part G. Same type, only little differences. Okay, what do we have here? Part G. Tan square 2 theta equals 3. Tan square 2 theta equals 3. We are given only the range of theta. What is the range of theta? 0 to 360. So if we solve this one, we can solve it easily. Now you can just do the completing. You can use so many methods to solve this. If you take these three other side, you have tan squared 2 theta minus 3 equals 0. One is you can make this as difference of two squares and solve it. I will show you how many methods do we have to find tan 2 theta. By putting a square root 3 and power 2, you can find it. That is one method. Other method, you can consider this as a normal one like you did in O levels, like you just get the tan 2 theta equals plus or minus square root 3 in the other side. That is the easiest one for this. And other way, you can use the equation. What equation? You can use x equals minus b plus or minus b squared minus 4ac divided by 2a. How? A is 1, b is 0 because there is no tan theta term, and c is equal to minus 3. To substitute this, it will be same. So any three method you can find tan 2 theta. So I will use this middle one. It's the easiest one for this one. So tan 2 theta equals plus square root plus or minus 3. So 2 theta, tan 2 theta equals plus square root 3 or tan 2 theta equals minus square root 3. So 2 theta equals tan inverse square root 3. Or here 2 theta equals tan inverse minus square root 3. What do you get? You can easily get a value in the calculator. This is a very famous value. No, how much you are going to get? Shift tan inverse square root 3. How much are we getting? 60 degrees. Now, if it is minus, it's going to be minus 60. No, easy. You get plus 60 and minus 60. 60 degrees, and here 2 theta equals minus 60 degrees. So we know this 2 theta here, for we can just divide by 2, and theta equals 30 degrees, and theta is equal to how much? Minus 30 degrees as well. Is it enough? No, we know this is between 0 to 360. Then you can just draw the tan curves. Square root 3 was here. And minus square root 3 also here. Tan theta, this theta curve. This is 0. We have square root 3 and this is minus square root 3. We have this value at how much? 2 theta was 60 degrees. Now here 60, this is minus 60, this is plus 60. How many positions we have before 360? This is 360 degree point. How many points? Only two. This is 1, this is 2, this is 3. And here we have, no, we don't need this one, no? And here we have another 2 more. So altogether 4. One is 60, other one is how much? It is 180 plus 60. So theta should be equals to either 2 theta equals to 60 or 180 plus 60. That is going to be 240. How much? Oh, theta equals 30 degrees or 120 degrees. Okay. And here from this one, this is minus 30, this is going to be 150, and here 360 minus 30. So other values are going to be 150, sorry, not here, no, 2 theta, 150 degrees. So here you will have 330 degrees. So theta will be equals to how much? Dividing by these 75 degrees and 175 degrees. We have 4 solutions, no? Is it 100? No, no, I don't think. 300, 150, 165, no? Are we finished? Are we finished? Are we finished here? So Dinesh is saying something. What Dinesh is saying? Minus pi to plus pi is the range. How you say like that? Sure. This is not finished actually. If you write like this, you will get for the final answer, you are going to lose marks. There are more solutions. This, we have to draw this graph for not just what? This is second cube. What you have to do? What is the fault that I did? No, no. This is not the question number 2. This is question number 1G. Okay. This is question number 1G. What is the fault? What is the fault? Actually, there is no fault, but it is partly done. This is not fully done. That's the case. Why? This graph is true only for 30 to 360, but we are dealing with 2 theta. We have to be careful about the range of 2 theta. We have to draw the graph for until 2 theta. What is the range of 2 theta? We can multiply all of these by 2. What do we get? 0, 2 theta, and this is 720 degrees. So you have to draw this graph until 720 degrees. Okay. If you just stop here, it's going to be wrong. So don't find the final answer. This is not the final answers. So what is our duty? We have to draw now 4 to 3 720 degrees. So yes, draw them quickly. We have how much? 90 degrees here, 180, 270. Oh, it's not going to be enough. What will be the best way? Let's take this as 360. So then this is 720 here. So then half is going to be here, no? It's like 360 here. Tan 2 theta. It will not tan 2 theta, tan theta. Now if you draw a line at square root 3, how many solutions going to come? This is square root 3 and this is minus square root 3. How many solutions are going to come for 2 theta? See, I will use red pen. 1, I will write A, here B, here C, D, E, F, G, H. All of these are solutions, okay? So you see, by it's just plus or minus 60, no? We can just get this. I'm going to write all the solutions now at once. Okay. So 2 theta is equal to how much? One value is 60. A is 60. B is going to be 180 minus 60, 120 degrees. C, 180 plus 60, 240 degrees. D, 360 minus 60, 300 degrees. E is going to be 360 plus 60, 420 degrees. Then F is going to be 480 degrees, 600 degrees, and 660 degrees. Is it clear? Yes, 660 degrees. All of these are possible answers for 2 theta. So theta means dividing all these by how much? 2. So 30 degrees, 60 degrees, 120 degrees, 150 degrees, 210 degrees, 240 degrees, 300 degrees, and 330 degrees. If you substitute any of these values, this equation is going to satisfy. Understood? I don't think it is hard. It's just identifying. There are so many solutions. Okay, I'm hoping to stop at 2. Don't worry. Okay. I also have a family life. Okay. Shall we do one more? Like which one? I'm not going to get the solutions for question number 2, B and D, but I will show you the path. Okay. B and D, I will show you the path. I think now drawing the graph and getting these angle values might be familiar to you, but the beginning of the is the thing. Okay. Beginning is the just wanted thing. So for the question number 2, what do we have for B? Question number 2B, we have what? Tan squared theta equals 2 tan theta. So now it is like x squared equals 2x, no? If we just divide by x, you will have x equals 2. Don't do it. Why? It's going to leave you if sometimes x can be equal to 0 also, no? If that is the case, this is totally wrong. Why? You have divided by 0. It's not a defined situation. So what you have to do, take them to one side and factorize. So you can write this as tan square theta minus 2 tan theta equals 0. So you have tan theta, you can take out, tan theta minus 2 equals 0. So you have now two solutions, either tan theta equal to 0 or tan theta equals to 2. Now, now follow the same process. Okay, now follow the same process. It's the directly you can get from the graph. Why? These are just uh, single angles. Okay, we don't even need to worry about the change of the range. It's the given range, just pick up from the given range. Then part D, what is part D? 4 sine theta equals tan theta. 4 sine theta equals tan theta. 4 sine theta equals tan theta. How can we solve? Hello. How to solve this kind of a question? Now we have two ratios. No, we have two ratios. So to deal with this one, it's okay. Always need to convert into one single ratio. You can consider this as sine theta divided by cos theta. Okay. Now you can see the both sides you get sine theta, no? You can cancel off here. So we have 4 equals how much? Uh, we have 4 equals 1 over cos theta. So if you make cos theta as the subject, cos theta equals how much? Uh, you can have 1 over 4. Okay. Or else if we take everything to one side. Now, this is also might be wrong. No? You might question. So in the earlier situation, I asked you not to cut off tan theta. So it's best to take everything to one side. But definitely this can't be equal to 0. Why? If that is equal to 0, it's going to be undefined situation. Okay. So you can cross multiply with cos theta and take everything to one side without cancelling. Okay. So you will have what? 4 sine theta cos theta equals sine theta. And now take everything to one side. So 4 sine theta cos theta minus sine theta equals 0. So now you can take sine theta out. So sine theta times 4 cos theta minus 1 equals 0. So you have two solutions now. Sine theta equals 0 or cos theta equals 1 over 4. So you have to solve for draw two different curves, sine curve and cos curve. Find solutions from the sine curve, cos curve, and all the solutions you can take. Okay, everything, everyone clear? Just you need to finish it now, no? Okay, so thank you very much for your help in this day. Let's see, I will let you know in the tomorrow morning whether we are having tomorrow or not our class. Okay, I think it is not a problem for you even though I continue tomorrow. Okay, thank you, see you tomorrow.